Welcome, everybody. We're going to be working on chapter 3 today. We're going to begin by doing some lecture, and I'm using the author's PowerPoints here. This comes from Murach's MySQL 3rd edition. As I was mentioning to my students before I hit the record button, my intent here is to cover the materials that I feel are critical for getting our homework done and for moving forward in the class. There are something in the order of like 60 slides in here, and I do not plan on hitting all of them. Some I will go through very quick. Some things I will demonstrate. Some things I will just talk about. But my intent is to try to move fairly quick, right? I will do demos as we kind of move through to match up with what we're seeing on the screen. And then hopefully you guys can do the same. And I'll give you guys that opportunity to follow along if need be. The end part of class will be covering the homework step by step. And I'm not sure if I'll do that in a separate video. Likely, I probably will. Or if I'm just going to bundle it into this, we'll see. You know, that is a TBD kind of thing. All right. So the objectives for the chapter are this. We're going to learn basically our first and arguably maybe the most key SQL statement, which is the select command, right? This is one that we use all the time because this is the command that extracts information from the database and allows us to see it, right? So without that, there's seemingly not a lot we can do without being able to look at the data in a database. There's a bunch of different other related topics to it because not only can you choose to view the contents of a database, but there's different methodologies depending on what you want to look at and how, right? And this is kind of the beauty of working in a database environment because you can sometimes take that content and adjust it to suit your needs so you get the display that you want and need as opposed to what's available, right? So that's kind of a good way to kind of put it together. All right, so let's look at the remainder of the objectives, and then let's move into the first little slide here. So generally speaking, the select command has one major command, right? And that is the select statement itself. But you'll notice that there's all these other keywords that are very typically used with it. So select will be a statement that says what we're selecting. From tells us which table or object we're selecting the information from. Where is the clause that gives us the criteria or conditions under which we're searching? And then order by is, are we like listing it in order alphabetically or reverse alphabetical or numerically or what have you? And then in some cases, we'll put in a limit, which will, in many cases, just limits how many results we put on the screen. All right, so those are the general commands that we're going to go through.
Can I ask a question?
Yes, absolutely, George, please do.
Why do they call these things clauses?
Because when you're putting together a statement, the statement can sometimes be simplistic or it can be actually very verbose and complex. And it's not a matter of, like, for example, like so take a look at this example here. We say select star from invoices being our table, star being what we call a wildcard, meaning we want everything from the invoices table. But sometimes, if I was looking at this table and I just want like the ID, the invoice number, and the total, okay, well, that becomes a little bit more of a phrase, right? Because I'm selecting multiple items. And then sometimes.
But as I understand it, the word select is a clause.
Yeah, that's a good distinction, right? So like the clause is actually the keyword in combination with the database keywords that would follow. So for example, in this example, the select clause includes the asterisk, the from clause includes the invoice, and it can be very simple like this, or it can be complicated. Yeah, it's really a good question because you're thinking in terms of semantics here.
Yeah.
Right? Yeah, and so it's kind of like the beginning of a clause is maybe the better way to see it. And sometimes when you're selecting, it is very simplistic, like just a wild card.
Okay.
All right.
That was for the digression.
No, it's quite all right. It's a very valid question, and I know that like if you guys watch or read this stuff in the book, you might have the same question. I don't get it. Why is it a clause? In other languages we just call it code or statement, right? Why they call it a clause, it just comes from the people that designed the technology in the first place. I think that's part of it, right? Databases generally pre-existed a lot of the coding languages we use today, so they have been around a little bit longer than like Python. So interesting just from that standpoint. Now they are using a database here to do these select statements. So I'm going to encourage you guys that maybe you can try some of these commands as we're kind of watching me do them. And I think that's really valuable to do. So I'm going to, for right now, go back to MySQL Workbench, which I have up and running on my screen already. If you don't, please go to your start menu, start typing MySQL. This assumes you have it installed, of course. And then when it comes up, just click on it and bring it up on screen. Normally, if you're running a local instance, you have that little gray box on the main screen that you click on and connect to your server. You may be prompted for your password, which hopefully you wrote down or remember. And then you will connect and you end up here in the main interface. Now, where we're going to begin is right now, you can see I have the My Guitar Shop database loaded up. That's for our homework. But for the samples from the chapter, we're going to use that other database in the course. And I'm going to go back to the course here just to show you. So not the My Guitar Shop, but the MySQL sample database classic models. And you'll notice that I have a link to it. So you can just click this link and it will download directly to your machine, assuming you didn't already do this. If you did this already last week, by the way, it's probably in your downloads folder. So if you just go to your downloads folder and find it, like for example, I have it multiple times, it seems, but there it is right there. So I know where it is now, right? After I've grabbed it, now I'm going to go back into MySQL Workbench, and now I'm going to load up that database. And that way we can follow the examples from the book, right? Okay, so here goes. The process for doing that is you can either go to the File menu and choose Open SQL Script, or what I tend to do is I just go to the second icon, which is Open a SQL Script in a new Query tab. So I'm going to do that. It's already in my downloads folder. Thank you. And then we'll click on the MySQL sample database, and it's got a .sql extension. Right. So once you find that, go ahead and click open. And that basically is a script file that not only, basically defines the database, but it builds the whole database. So what I'm going to go ahead and I'm going to run the execute button right now, which is the lightning bolt. And that builds the database. And then when I come back here to my schemas tab, right, you see the schemas tab, right? You might be here, switch over to schemas, hit the little refresh, and then you'll notice that you'll have the new database loaded up and it says classic models. So that's the one that they're using in the samples in the book. So you will see, like, for example, some of the same, hopefully, content. If not, if I'm mistaken here and they're using the Sequila database, then I will switch over to that. But I'm thinking that we're going to be okay here. So I'm just using this one just as an example, and hopefully we can get some of the similar content here. And I think I may have already shot myself in the foot, and that's kind of weird to admit because I'm not noticing an invoices table. You guys picking up on that? Yeah, no invoices table here. So I'm thinking that is the Sequila database. So you know what? Since we're in the process of doing that, and I know that anybody watching the video later is going to be like, what the heck are these people doing? But why don't we go ahead and I'll show you where that database is, because if you're following examples, it's kind of nice to have them match up. So I'm going to go back to our course main page, in the content area, and then way down here at the bottom there are course resources. You guys with me? I don't want to go too quick. Let's go to content and then course resources. And then you will notice the Sequila, I think is the right way to say it, database, and it comes as a zip file. So I'm going to go ahead and click that, and then you can download the database. Now this one has a slightly more complicated approach to installing it, which is why I tend to stay away from it, for examples largely, but here we are in the situation where we want to match up, so we're going to use it. Since it comes as a zip file, you do need to double click that zip or right click and extract all. So this will be different if you're on a Mac versus a PC, and it will look a little different if you're on Windows 10. I'm on Windows 11 right now, but I'm going to go ahead and extract all. Keeping it in the download folder is fine for now. Once you have it extracted, you can go into the folder and you can see that there's two different database files here. And what I'm going to do, and this is kind of a weird kind of thing to show you, is I'm going to bring in just a generic text editor here really quick. And I want to show you what these files look like, right? So one has a bunch of information in it. This is actually the data for the database. So we don't want to run that SQL file first, but really what we want is this schema file, which defines and creates the database. You see that command right there? So here's the plan, basically. We're going to load this file first to set the structure for the database. That's what a schema is the structure, like the framework of a house. And then we're going to load the data into the structure that we built. You guys ready? So this is practice now. We've already loaded one database. Now we're going to load another. So let me just pause for a second. All right. I'm going to now go back to MySQL Workbench, and just kind of the same way we did this, I'm going to close this SQL file, just a tab. I'm going to go back to the Open SQL file thing. I'm going to find my unzipped folder in my downloads, go in there, and I'm going to start with the schema. So I'm going to open that schema file. And then I'm going to go ahead and also open the other file right away. This seems kind of silly, but that's what I'm going to do. So I'm going to open the other one, and that's going to come up in a separate tab. Right now, the data tab is highlighted. I'm switching back to the schema tab, and then I'm going to hit the execute button and watching the status window down below. And I think we're okay. I'm going to hit the refresh to see if I have it loaded. Okay, well, it's down here. Okay, so it's there. So you notice that I now have 3 databases all loaded up. So once you have them loaded up, you can actually access all of them simultaneously. But now I need to execute the data file. So I'm just going to flip to that tab, hit the lightning bolt, and that will populate all the data. So now when I come in here and I look at, this doesn't have an invoices either. Now I'm getting a little upset. Right. All right. So whatever. We'll figure it out. We'll just work around those weird examples. But you can make sure that it's working by just looking at one of the tables and seeing if there's information inside of it. So if you see the information, fantastic. Is everybody with me? Okay. All right. So now I'm going to close all these tabs because we already did the work that we need. And you can tell I'm a little flustered with the lack of the invoice table that they're using as an example. And it's like, where the heck is that coming from? And I'm not really sure. All right. So we're going to just kind of dynamically adjust as we go. But let's go back to the slideshow now and try to get back on track. And I apologize for the sideline, but at least we have a little bit of practice opening new databases and executing their scripts to build them. And now hopefully, by virtue of doing this, you have all 3 of those available. And if you don't worry, we will circle back and make sure that you do. But here's a really simple little statement that you're seeing. And this is kind of like the crux of where we start when we do these statements or clauses. And going back to the whole naming thing, I mean, check out how they're even calling it a simple select statement, right? Select is considered a clause, but I always think of the clause as everything that comes with it. This select statement involves all the clauses linked together. So maybe that's the answer, George, is a statement is a collection of clauses. Maybe that's the tie-in piece. All right. Given the fact that we're working right now in the Sequila database, or at least we want to, right? I'm going to go ahead and create a new SQL tab. So you see I hit the first button in the toolbar. It creates an empty code window. And I want to make sure I'm using this database. So I'm going to type what we call a use statement. So I'm going to type use Sequila semicolon. And I know that's a little small, so let me just do you the solid of making it huge. Bigger, right? Larger. So now that I have that there, I'm going to hit the lightning bolt and it will execute the statement. And all that does, you can see down here, it worked, right? Because this is our output. It just says, okay, now you're attaching to this database. So all subsequent queries are going to that database, not the guitar shop, not the classic models. Excuse me. All right. Since I'm not finding that magical like invoice, table in any of these, you know what? We're going to end up doing our homework on the guitar shop. So let's just do the same thing with the guitar shop then. Let's change this statement and I'm going to say use my guitar shop. And then notice, folks, the database name is all lowercase. There's underscores in between the logical words, and I'm putting a semicolon at the end of a statement. Now, semicolons are kind of interesting in and of themselves because this will work if I execute it. So you see it worked. But I can also remove the semicolon and hit the run statement, and it still works. So what's the point of the semicolon? The semicolon is basically a way, if I have more statements inside this file and I want to execute each one as a separate statement, the semicolon is kind of like a separator. So if you have one statement, you don't need it. Kind of interesting. If you're creating a script file like the ones that we opened that built those databases, then you need it to separate every logical statement. That's kind of the purpose of those. There are some database systems where it's always required, just a heads up, right? All right, so now we're attached to that database. I'm going to actually leave that command there, and I'm going to demonstrate something kind of interesting here because I do see all the different tables, and they have addresses, administrators, categories, customers, blah, blah, blah. And how about we look at the products table? I don't really know what's in the products table, so I can kind of figure it out two different ways. I can use the little expander, hit the columns, and now I can see the list of all the columns inside there. Another real practical way is I can highlight products here in the sidebar, and that third icon will just give me a dump of that table on the screen, which frankly is quite helpful because now I can see the whole table, all the columns, and the information inside. I want you to notice that it did open up a separate tab here, and it also did a select statement automatically. So it wasn't really like this magic piece of software that did it. It was really the execution of a select statement. The asterisk, at least in this format, represents what we call a wildcard. It's like select everything, from the table. Now, notice that, it didn't just say products, it also prefaced it with the database name because the little icon doesn't know that I already typed use my guitar shop. However, if I delete that and run it again, it still gives me the same result because I'm already attached to that database. But if I wasn't, this would give me the way to attach to it if I was running a different database. So there's some circumstances where if you're working with 4, 5, 6 databases all at the same time, that you do statements like this to make sure you're attaching to the right one. So it's the table, but we also have the database name prefaced. If you use the use statement, that prefacing statement is irrelevant. Now you can practice that command here if you wish. We can also go to a different database and try it, but that's like the basic lay of that command is to select from, you select everything from which table, right? If I want to try that on the order items, for example, I can take a look at that table, see what stuff's in there, and then I can just write, uh, the same kind of statement here. Once again, you could remove that and execute it, and you can see it gives you the same result. So you can see the whole table that way. Right? That's the first and most fundamental of all the select statements. Now, great, right? That's helpful for being able to see everything that's in the table. But often, if you're really doing practical work on a database, you don't need all of it. You just need the parts that you need. Like somebody might say, hey, can I get the invoice number, invoice date, and invoice total? And maybe like in our guitar database, we could really kind of maybe look at maybe the orders would be a good one. So let's take a look at that table to begin with and the stuff that's in there. And you'll notice right away that, there's a number of different orders. And I'm trying to see if I can zoom in on that panel, but it's not working for me here. Anyhow, notice all the fields that we have. So order ID, customer ID, order date, ship amount, tax amount, whatever. But if I don't want all those pieces of information, for example, if I'm doing a report from a database, do I want to really put the customer's credit card number up there? Probably not. Right. This is one of the issues that's happening in a lot of hacks, right? Is a lot of companies do store credit card data, right? And there are people that get access to it, and then they get hacked, or somebody gets the password, and then your info is compromised. So kind of interesting thought. But let's say, for example, I wanted, instead of selecting everything from the orders table, I just want to select very particular pieces of information. So I'm going to kind of lay it out like this, and I'll show you kind of my methodology. Why don't we do, how about order underscore ID, comma, and let's see, what would be another good piece of information? Maybe card type. That's kind of a weird one. But notice as I type this stuff in, that it does auto recognize that it's coming from the table and tries to help me type it in. The other thing that I'll point out is people have different formats for typing in these statements. So here's an example. Some people will type them in like this if I'm selecting multiple pieces, and some people will just use the approach like this. So I want to get order ID and card type from orders. I'm going to go ahead and execute this statement, and now you'll see the result set change. So now I'm just pulling those two pieces of information back. Say, hey, for order number 8, what kind of card did they use? Oh, they used the Visa. Anybody have a question? You guys okay? Right. So the point of this is the select statement doesn't have to pull back everything. The select statement can just pull back the columns of information that are necessary for whatever you're doing. Right? Whether you're writing a program or you're just grabbing information. Okay, so that basic example. Next thing that we kind of add to the mix is we have this, what we call a where clause, right? And the where clause is where we add additional criteria. So we're looking, in this case, we're using where the invoice ID equals 17. Now we could apply that actually to our statement here. So I'm going to actually add a line, and I'm going to say where, got to spell it right though. And notice I spelled this lowercase. Is that a problem? No, it's not a problem, by the way. And I, real frankly, I learned the old school way, which is all the keyword commands in SQL should be uppercase. And that was the only way it worked in the old days. These days, it doesn't care. You can go uppercase, lowercase. And because those are keywords, you can't use them as database table names or database names or column names, right? Now, we're going to select a criteria here. So we're going to select order ID and card type where, how about order underscore ID equals, let's just pick a number, 5. Okay. And so now I'm going to run that. And now it's giving me just order number 5. Now think about this. Normally, like if you're trying to extract data from a database, you're probably not typing a straight up query command. You'll probably have some sort of interface and a piece of software that says which order you're looking up, and somebody types in order number 5, and you press enter, and then you just pull back that information. But in the background, the query that's being created is something like this. Right. Or, for example, instead of saying equals 5, we could say maybe greater than 5. And then we could run that command. And now notice that it's 6, 7, 8, and 9 are popping up, right? So we can qualify it, right? In this case, because the ID is numeric, I can use mathematical symbols to identify it. Okay, what if instead I was doing something like this, where card underscore type equals Visa, right? And notice I did lowercase. Is this going to come up with any results? Yeah, it doesn't care. Didn't care that it's uppercase or lowercase, right? So we need all the people I paid with Visa, or all the people I paid with Discover or American Express. That's totally doable. Right. Let's keep moving on. So that's adding the where clause, right? And then you'll notice that you can use it in a bunch of different ways. So for example, in this example, they're looking at invoice date, and notice the keyword between, right? Invoice date between a certain date. Look at the date format. It's year, month, day, not what we're normally used to, and this date. And it will set basically a limit and a parameter and pull the data from between those areas. They're throwing in another wrinkle here, though, right? So we not only have a where criteria, we also have how are we ordering this? So in other words, they're looking at the invoice date for the ordering. And if they're looking for all the dates between, June 1st and June 30th, and we had a whole bunch of them, they would start at the 1st and it would go down sequentially until it reaches the 30th. So we cannot not only extract the information, but tell it how to sort the information for display. That's pretty helpful, right? If you're trying to track something down and it's in order, it's a whole lot easier. So that's the order by clause. Sometimes you will run queries that come back with nothing. Nothing matches your search. Right. So, in this case, they're looking for an invoice total greater than 50,000. What about like for ours, if I did where the card type, I don't think there was a Discover card in there, but let's try it. Maybe there was and I missed it. Oh, there is one. Okay. Maybe I can put my Diners Club in there. I'm sure that one's not listed, but whatever. All right, moving forward. All right, so what I think is kind of interesting here is that all of these statements often have ways that you can kind of expand on them and do like really kind of intensive things. So like not only can you identify the column, you can also use what they call this as result column. So you might actually do some math between a couple of columns and then display the result in a separate column, or you can rename an output of a column to something else that makes more sense relative to what you're doing. Right. And we'll do some examples on that, but the basic things you can do is you can take all the columns in a base table or just the column name, or you can do some math, or you have a function that then becomes aliased as a separate output. A little beyond where we're at right now, so I'm kind of rifling through it kind of quick, right? The asterisks, once again, that's the wild card, right, in the coding. So you can retrieve all the columns that way. So you don't have to specify which columns. If you find yourself listing all of them, well, then you're just wasting your time, right? If you do need only specific ones, you have to label them one by one. All right. Here's an example of one that's using a calculation. So they have this example of like, you might have an invoice total, and then there's a payment that the customer made, and then they got some credits or, whatever. And then the result of that math. So it'll pull all three columns. It will subtract payment total from invoice total, then subtract credit total from that. And then it will display it as a separate column called balance due. So you get the math result there. And this is really, and I always call it an alias because I'm kind of like stuck in like old school Mac thinking, but it's like we're renaming it as something else. And let me see if I have an example here that I could even show you. So for example, let's look at the orders table. Right. So here we have like a shipping amount and a tax amount, for example. So I could, in principle, from the orders table, and I'm going to move that down to the next line, I'm going to take the ship underscore amount plus the tax underscore amount, right? And I'm going to display that, and I'm going to do it on the same line. So as, and I'm going to just call it something really lame like ship underscore tax subtotal or something like that, right? And then I'm going to run this and watch what happens, right? So it creates a new column that didn't exist that has the result of the calculation stored within it. Kind of an interesting thought, right? So this is an example of doing some math and then conglomerating it in a new column that didn't exist before. Okay, so if you have a question, is this adding it to the database? Nope. We're just using the information in the database to generate other information. So we're using data to create information, right? So this is kind of, I think that's an important concept to latch onto in and of itself, but very, very common. Another really kind of interesting example, and this one's actually in your homework, so hint, 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 go to this slide if you're stuck on this one, but I will demo it later, where we have this function, and we haven't really learned about functions yet, but basically there's a function called concat. Does anybody know what concat stands for? No, nobody's coded before? All right, well, concat is a short way to say concatenation, and I'm gonna, for concatenate, right? And what does concatenate mean? Basically, it means to take a word and join it together. So for example, if you look at what it says here, for example, the concatenation of snow and ball is snowball. So concat basically stands for joining strings of text together. So what this command basically does, and notice the format for this, right? We have this keyword, which is the function name, the concatenation. We have a set of parentheses, and inside there, we're going to take the first name, comma, a space, and then add the last name to it and display it as full name. And in fact, we can just try that a little bit because I'm sure we have a customer table here. And you notice what I'm doing here is I'm using the table display to kind of shortcut my code a little bit. But we can probably almost borrow this verbatim, hint, hint, right? Sometimes you can do that because we do have first name and last name, right? But they're in separate columns. So I'm going to replace the asterisks here with the concat statement. So we're going to concatenate first name, last name as full name from the table's customers, and then watch the execute here. So now I have a full name output, right? Okay, so how would you use something like this? So I'll give you guys ideas, right? Like, so as either a software developer or like a web developer, right? You go to a website, chances are somebody has an account with you, they log in, first name, last name are probably in two separate columns in the database. And then when they log in, you say, welcome, Joe Smith, right? And so that's a situation where you might use something like this. Jonathan.
I don't know why it keeps doing it. I'm not even clicking down there.
Oh, that was a mistake.
It's doing it on its own. Like my mouse is even on my monitor right now. It's
Okay,
clicking
well,
on it.
not a big deal. I sometimes do that too because like the Zoom toolbar can be a little quirky.
Yeah, no, I'm doing doing whatever.
All right, I'm gonna keep pressing forward, folks. Um, some more examples. Okay, so here's an example of a select statement that takes the column, renames the column in the result set. So even though I might be pulling an invoice number, you got to admit that doesn't look as nice as this does, right? So like if you're going to take your table output and display it to somebody, you might do something like this where you're just changing the name. So when it appears in the result set, it's not a goofy looking cryptic column name. This one's actually not too bad because it basically says what it is. But sometimes people abbreviate. They might go like INV underscore NUM and leave it at that. You have to admit that this is a little bit nicer. So the as command basically allows you to create an alias for one that already exists, right? It's a renaming. You know, invoice number can be invoice number, invoice date can just be date, invoice total could maybe just be total. And you have to admit, these are a lot cleaner to read, right? For sure. And I didn't mean to jump that fast. Okay, there we go. Meaning to scroll and I just go too far. All right. Okay, select statement that doesn't name a calculated column. So this is kind of strange. Like if you do end up doing math and you don't put an as statement at the end, and guess what happens? It just takes the whole equation and puts it in the column header. Not useful, by the way, right? It is better if this had an as statement to say as total or as balance due, something like that. That would make a whole lot more sense. Yeah, and you know, I should probably do this. This probably helps a little bit. I know that we don't have a huge amount of screen space, but every little bit bigger helps. All right. So now we get to this point where it's like, oh, I can take the database information if it's mathematical, if it's a number, for example, and I can do math with it. So just like we will learn like in programming, so many of you guys that are in the Python class later, there's mathematical symbols that apply in programming, and some of this stuff might be new, right? So typically when you're in school, you learn how to do add, subtract. Hey, fortunately, addition and subtraction are still the same characters, right? Plus and minus. Multiplication isn't an X, it's an asterisk, which the shift of the number 8 key. You also see it by your 10 key if you have one on your keyboard. And then division is the forward slash, right? So those are the typical. So addition, subtraction, multiply, and divide. But then we have these two other ones that are kind of weird. So the first one we'll talk about is, and this is very unique to SQL, by the way, what we call integer division. Every language handles this a different way, by the way. So when we look at it in Python, you'll notice a different approach. When you look at it in Java, you'll notice a different approach. So, but integer division is where we basically do the division and we don't care about the remainder. We omit the remainder. So if I take, let's say, I don't know, 3 and divide it by 2, I would have a remainder of 1. If I did a div command instead, I would just get 1 because 2 went into 3 once. I don't care about the remainder. Now, if I do the remainder, which is called the modulus or modulo operator, or remainder division, basically, we use the percent sign, and the percent sign just gives us the remainder. So if I were to divide 4 into the number 5, I would have 1 left over, and it wouldn't give me the one that went in. It would give me whatever is left over, and then I can use that to do other mathematical operations. It's hard to explain what the great purpose of that is without examples, but generally speaking, some of this stuff was developed by something really simple like making change. Because if I have, you know, I buy something for 79 cents and somebody hands me $1, how do I know what number of coins of what type to give back? Right. And in the old days, when I learned how to like run like point of sale, like retail with cash without a cash register or a calculator, you just have to figure that stuff out. Right. And these days you walk into a store and you give somebody, a $20 bill and they don't know how to make change if they don't type it into the cash register. And often some of the modern systems will say 2 quarters, 1 nickel, 1 dime, they'll tell the people tell them what to give back. It's kind of interesting. Right. But modulus is partially developed because of the necessity to make change originally. So the point of this one, going back to it, is when you do the math, right? And notice I suggested balance do. That's what they're doing. So they're doing the math and then they're displaying it as balance do. And that makes sense, right? Now, I would argue, right? Like if you're going to go to that trouble, why not do the approach that even looks nicer and make it a capital B, put a space in there and a capital D. You could do that too, right? It's just output. Remember, it doesn't affect the contents of the database. We're just using the database contents to create more information. All right, moving on. Another thing is if you do run into situations where you're doing math, and this is an order of operations thing, right? Have you guys ever heard the acronym PEMDAS, right? You guys ever hear that, right? Which stands for the order of mathematical operations, which is basically in order of precedence. You do what's inside the parentheses first, then you do exponents, then you multiply, then you divide, then you add, then you subtract in that order. And if you look at certain things, like for example, this invoice ID plus 7 times 3, which piece of math happens first? The multiplication happens first, right? And then the addition. So this would be 21 plus whatever the ID is. This one would be different because you're doing the addition first and you have to force it if you don't want it to multiply. So that's a common thing. Once again, if you're taking a different coding class, the Python one is probably the most notable one for most of you. We will talk about this and demonstrate this. If you're not sure, you have to test your math, basically, to make sure you're getting the right answers. Often, and I know people get all freaked out on this stuff, it's like, oh man, I hate math. I'm not good at math. I stress out on math. Remember, if you're a pro working within a big company and stuff, you probably have an actuary or an accountant or somebody giving you the correct formulas, right? And then if you know you're not getting the right answers, that's one of the things to look at, by the way. All right. They have examples here of the divide or the div and the modulo operators. Once again, I don't want to get super deep into this, and I'll save it more for the Python class when we get to the math stuff. But generally speaking, it's kind of interesting. So what you take your invoice ID, right? And you divide that by 3, 1 divides into 0.333. Okay, that makes sense, right? That's just normal division, how it would come out. If I did as an integer quotient here, and this is where it gets kind of interesting. So if I divide 2 by 3, it doesn't go in there at all, right? So the quotient is 0. It never fits. We're only looking for the whole number answer, not the remainder. Then the weird thing that happens with the modulus operator is now we're taking 3 and doing modulus 3, and we're just looking for the remainder. What's the remainder of that? 0. Right. All right. So you'll see that as you go. Not anything to really stress on too much. They do talk about the order of operations, right? And so they kind of go through that whole thing. And I'm not sure where the other stuff is, but you know what? You can look up this PEMDAS, and I don't know, like some people will abbreviate it like, please excuse my dear Aunt Sally. That's a good one. Pizza every meal, whatever. You can come up with your own acronym to remember, but it's a pretty simple one. Chances are they probably grilled it into you in high school. All right, so if we do the concat command, basically concat is a joining of text, right? Which we've already demonstrated. And what can you concatenate together? Well, anything that's text. So if I have numbers, I can't really do it. But if I have text, like for example, if I concatenate city and state, and I don't add like the punctuation in between, like what we did here, where we put in a blank space intentionally, then your output is joined. It's literally touching, which may or may not be what you want. I would argue that they probably want to do here what we did here, right? Which is to add another parameter basically of a blank space because it looks nicer. Okay. Moving on, we are going to take a break here pretty soon, just in case you guys are getting antsy in your chairs. I get it. I just want to hit a few more slides before we do that. Now, what if you wanted to do like the city, state, and zip, and then you also wanted to put a comma in there? Well, yeah, that's doable. So you can do the city, comma, here's a single quotes, so a comma space, and then the state, and then a space, and then the zip code. And then you can format it so it looks really nice. Now think about this. If you're using the database information to generate the address that would go on a label for a mailer, you might do something like this, right? You let the database feed in the information, and this helps to format it so it looks nice. Right, and that's all done with what we call concatenation. All right, so, but what if like you want to add an apostrophe, right, in the middle of that? Well, that's kind of weird to do because take a look at how this plays out. So the vendor name apostrophe S, right, address, but all of that sits inside there. It still works. This is really kind of a really weird kind of format for doing this. But in essence, we put in an extra apostrophe to allow for the second apostrophe to be ignored. Caught that? That's a little bit different than other programming languages where normally we would do like a double quote and then put the single quotes inside. Now you haven't learned that in other languages yet, but you will, right? So that one, don't worry about it. We're not doing that right now, but I think that it's helpful to know. So some of the terms that we are kind of throwing around here, and I don't know if you've picked up on them yet, but you'll learn these as you learn your programming. A function is a pre-built tool inside of any language that allows you to perform a specific task without you having to code for it. So like concatenation, the joining of strings, is a function. The stuff that we throw in between the parentheses, we call those either parameters or arguments. And then concatenate, once again, is the joining of strings. Those might be like quiz questions, by the way. So that's not a bad one to kind of think about. All right. So what I'm going to do here is I'm going to pause right here. This is a great place to pause. We're going to do a 5-minute break, and then we're going to come back and resume. So I'll see you guys in 5 minutes. It's 6:36. We'll come back at 6:41. All right, we're back from break, and we're hitting kind of the point in the PowerPoint here where most of the information that we already need to do the homework we already have, by the way. So a lot of the information that follows is, I'm not going to say completely superfluous, but it's not relevant to the homework that we're doing right now. But I'm going to cover the topics as fast as I can with the intent of getting to the homework before it gets too late. So I'm going to see if I can get through like 40 slides in 20 minutes. That means I have to talk really super fast, right? Maybe I should slow down the recording so that when I play it back, it comes back faster. I'm not really sure. Maybe it's the other way around. All right, so there's a bunch of different functions and stuff that are built in, right? And I want you to notice that here's one that's called the left function. And basically what it does is it takes the information. Notice that we're pulling first name, last name, and then we're concatenating it. And it says left vendor contact first name 1, right? And it's also doing it this way, but we're using basically the leftmost character of that string from each one of these to output the initials. So left takes which piece of data? Just the first piece of data from the left. This is kind of strange, right? So this could be like, hey, we just, maybe I just need the first 5 letters of somebody's super long last name to figure out who they are. So I might like, this might be 5, for example, instead of 1. In this case, we're just using the first character. This is crazy stuff, right? So I can take first name, last name, and turn it into initials. That's what left does, for example. There's also date, and this is kind of interesting because we can actually declare the format for the date and display it in the way that's useful to us. So when it goes into the database, the format is year, month, day, because frankly, folks, that's the most logical way to have a date, right? It's the year, the month, and the date. Here in the US, we kind of do it backwards, by the way, right? Like if you ever look at Europeans, they always do, they don't go month, date, year. They go date, month, year, right? And if you've ever run into that, you're like, is that June or is that, whatever. But you can also take whatever the format is, because in the database, it'll always be like this. And then you can choose how to output it. And notice how they have these like weird percent signs. So here's kind of another thing. The percent sign is to, is basically a way to throw in a wild card. So like if the month happens to be a single digit rather than a double digit, that accommodates that is really what it does, right? And so here they're basically taking whatever format it's in and then converting it to a format that works for us, right? Relative to whatever we need to see on the screen. So here's the American format. Here's the European format, right? With 4-digit, this one's a 2-digit, whatever. You can tweak that stuff. I think it's kind of, a little touchy feely, honestly, but hey, there's reasons for why we write the code the way we do. There's also another kind of interesting function called the round function, and where you basically say like what you're rounding, which thing it is you're rounding, and then how many decimal places you want it rounded to. So if I use the round command and don't have any decimal places, we exclude the decimal places. Interesting. If I want it rounded to 1 decimal place, I would indicate that as this. So the nearest dime, for example, would be this 0.2. And then what's very common if you're doing money formats is that's usually a 2. So it rounds it to the 2nd decimal place. This is sometimes, okay, if you're doing like a regular product, everything's rounded to 2 places already. But if you do something like gasoline, right, where it goes by tenths of a penny, it's like 279.9, right, that kind of thing, where it's really going beyond 2 decimal places. This allows you to round it and display that output. You can also do stuff where you're doing straight up math like this and just putting out an output. And basically notice that this select statement really just tests a calculation because you're too lazy to bring up your calculator or a spreadsheet or some other programming language to do it. So it gives you a way to kind of tool around with it. Not something I do very often, but interesting that it's available. Also, some examples here are statements that test the concat function. Kind of gets kind of in the weeds again. More date conversions, more rounding conversions. And then here's a statement that actually returns all the rows, but basically what we're doing is we're just ordering them by city. right? So there's a whole bunch of examples like this, and you can see why I'm kind of going through them quick, because it really is kind of beyond the scope. Sometimes when you are pulling data from a database, you just want to know, hey, can you give me a list of all the cities from which people are placing orders? Well, there's a good chance that you might have, like, for example, if you lived around here, you'd probably have a bunch of people ordering from Racine and a bunch of people ordering from Kenosha. I just need to know, are we getting any orders from this town or not? I don't need to see every single one. So there is a way to add a command called distinct, so that if we're looking at city and state, we just want, if Racine appears 500 times, I just want to see it once. I don't need to see it 500 times to prove the point. Right? We can do that in a separate operation. That one I think is actually pretty useful. When we're doing any sort of mathematical comparison, we use a lot of the standard mathematical symbols. So there's equals, greater than, less than or equal to, greater than or equal to. Then you have the two weird ones at the bottom. What does this one do? This is kind of a weird one. Yeah, these two are actually the same. So that's why I go to the next slide here. This means not equal to, and exclamation equal is also not equal to. The bottom one, by the way, is the more common one in programming. So you'll see that in Python, you'll see it in Java, you'll see it in C#, you'll see it in JavaScript. When you're looking at this one, the only other language I know that does this off the top of my head is Visual Basic. Does not equals to that way. Bunch of different things that they're looking at here with the where clauses and stuff being equal or not equal. And once again, I'm rifling through this really fast on purpose, folks. They give examples of how to do all these things. I'm not super concerned if we get to the point where we're doing that kind of math and this kind of logic. I will spend the time to explain it all out to you for sure. There's also this thing with this keyword in, right? Where basically we can look for information from a column, and if it's part of this information. So for example, if I had a column that had, like, I don't know, how many children people have, maybe that's it's a good example. And then if people have either one kid or 3 kids or 4 kids, then include that term. So it's part of that set of data. So it's in that set of data. You can also use the keyword not in front of it. So if I'm looking for a vendor state and I don't want to include California, Nevada, or Oregon, I can exclude them using that approach. We have the between keyword. We kind of saw a little bit of an example of that before, really common to use with dates. So I want to get all the invoices that are in between June 1st and June 30th from 2018. There you go. That's the statement to do it. So that's pretty normal. The other one that you can do is not between. So that there's a logic thing that goes with that. All right. So I'm gonna keep moving forward. We have a couple different symbols, by the way, that we use for wildcards. The percent symbol is very commonly used as a wildcard, and I will demonstrate that a little bit later. So in other words, like when we're selecting a piece of data, and like, for example, if I don't know how to spell a person's name exactly correct, I might use a wildcard. So like, for example, man, I don't know how to spell San Diego. I do, but I'm just using that as an example. If I'm looking up a city, I'll just use the keyword that the vendor city is like San, meaning it's starting with SAN, and then whatever else follows, whatever. So San Diego would work, Santa Ana would work. Kind of interesting, right? All right, moving on. There's this other language that we often throw into programming languages. This does get a little bit deep because this is kind of like referencey, basically. We have this secondary language for formatting stuff called regular expressions. And folks, there's entire books written on this. I'm not going to get into a whole talk about this, but regular expressions are supported in MySQL. And often regular expressions are a way to make sure that the data that's being put into our database is being put in correctly. And for example, here, we have a regular expression of SA, meaning that the content somewhere in that vendor city will have the letters SA in it. So this is just to enforce that things are working correctly. Not a big deal for what we're doing right now. So I am kind of rifling through this quick. I have a bunch of examples. Now here's one that actually might be useful for tonight. So that's why it was one of the ones I was trying to get to here, where we have this concept of this thing called null. And I want to really explain this really carefully. Okay, when we think of these concepts of like something and nothing, right? And if we were to do that mathematically, like if I was counting something, I'd say, hey, I got 5 fingers, that's something. Or I have no fingers, that's nothing, right? But that's 0. 0 is still something. I don't know if you feel where I'm going with this, right? Because 0 is still a number on the time or on the number line, but it represents nothingness. Null in computer speak means that that spot in memory has nothing in it. There's not even a 0. And that's why they're kind of showing the table like this. So 0 is not the same as null. Null is the absence of anything, including 0. So kind of a weird concept. I know that there's, here's an example. Like if I was looking at maybe an order or a customer table, and I'm looking at all these customers and all of them have cities and states. And then I get to one that's got a city but no state, and the state field is null. What's the scenario under which somebody would be in a place that doesn't have a state? Well, here's an answer. They're somewhere overseas where they don't have states. So they can't enter in the name of a state if they don't live in one. That would be an example. So we would leave that information null, basically. All right. So I am rifling pretty quickly through this, and I'm trying to find okay, so here's our order by clause. This is another one that's actually pretty important. So often when we're going to be running queries, we'll get output, and then we'll want to put that information in a format that makes sense for us. For example, if I'm going to be looking at the guitar shop and I want to see like, hey, what's the best guitar you have, or what's the most expensive guitar you have, I might create a query that outputs the prices with the highest one first, so it would be descending from the highest to the lowest. If I don't indicate whether it's ascending or descending, ascending, by the way, is assumed that we're counting up. Or if we're doing alphabetical names, we're starting with A and ending with Z. But if I take names and I sort them descending, I'm starting with Z and going to A, right? Once again, ascending is always assumed. Descending has to be declared. Smart programmers will actually say ascending or descending completely, by the way. We will play with that one in just a little bit. All right, moving on. We're getting there, believe it or not. So here's an example of the descending. So we are pulling the vendor name, concatenating the city and the state and the zip code as address, which you're seeing here, from the vendors table. And then we're taking the vendor name and we're sorting it in descending order. And notice the DESC, right? That's a keyword. You don't say the whole word descending, but this is a beautiful little example, starting with the letter Z and working our way the other direction, right? Another thing that you can do, and this is a little bit strange, is you can also use ordering that compounds columns together. So in other words, we're looking at more than one piece of information to do the sorting. Like, for example, you could sort by name first, and if you have a bunch of stuff with the same name, then you can sort by state or street number or whatever, right? So you can sort by this first, then sort by that. That's possible as well. We also have this thing, where we're aliasing once again, and here's actually a use of that term, because we're ordering by address, which is something that we're concatenating. And yeah, you can totally do that. That's pretty weird, right? All right. Moving faster and faster. We're getting to the homework, so hang on tight here. the order by clause can also use concatenated information within there. I'd say that's a more advanced skill, but there are times we need to use that. And then you can also choose column positions to do the sorting. So if you don't want to, like, say vendor name, address, and you already have the columns popping up, you can just say order by column 2 first and then by column 1. See how flexible it is? It's kind of crazy how flexible it is. Some of it is really kind of a legacy from older systems coming in there. Here's another command that we're not necessarily going to use today, but one we might use later, which is the limit clause. And basically, and this is really, really useful. Okay, so I've run into these situations where, for example, let's say I do a query and, I'm like, hey, I want to get all the customer orders for the last year. All right, because I just kind of want to see what the data looks like. And it's like, oh my God, there's 100,000 orders. Do I want to wait for all 100,000 to get listed just to see what the data looks like? So limit is a way to limit the number of results so you get a sample of what's in there without having to look at all of it, right? So I might have 1 million records, but I'm only seeing the first 5, right? That might be enough just to show me that it's working correctly. Or maybe I'm running a limit at a certain point because maybe this information is going out to a web page and I don't want to dump 1 million lines of text on the web page. I just want to drop 50 lines of text on the web page for right now. And then when a person scrolls, I'll get another 50. That kind of thing. So the limit command also very, very useful. Once again, you can run the limits based on which columns, right, with the clause. And folks, we have reached the end, right? And thank God, right? So I'll tell you what, I'm going to call this video done. We'll do the homework in a separate video. I think probably even the people on YouTube will be thankful if this video is over. It's a good hour plus. All right, folks.